plant, right? This is the plant, and today we will model the controller, right? So now what we are getting here, the speed information of the motor, okay, that is sensed, and we will take it from here, so that will come here, okay, and here is the speed reference. Okay, so these two quantity will be compared, okay, and one error signal will be generated here, okay. So now we will get here error, okay, the error signal. So this error signal we have to process through some controller, okay, and in this design we are just using PID controller, okay, simple PI controller. So take one PI controller from the library and connect it. So search for PID, you will get PID controller, okay. Either search on the screen or you can search here also in the library section. So here you can get PID controller. So you can drag and drop it here, okay. Now connect it like this. I will zoom it little bit. Okay, so now connect it. And after connecting, just hide its name, okay, by clicking right side on your screen and double click on it, make it PI controller, okay. So this one we will use as PI controller. Now we have to give some value for KP and KI, okay. So KP value I am going to take 0.9 and KI value is 4.9, okay. Then go to this PID advance, and here we have to define some limit, okay. So this limit is 550 to minus 550. Okay, so this is very important, okay. And this anti wind up feature also you have to consider on this PID controller. So for that purpose, this one also you have to take, okay. And in case of reset, we do not have to do any reset here, so just keep it as it is, okay. So again I am telling that you have to take the PID controller, double click on the PID controller, make it PI, then KP value is 0.9 and KI value is 4.9. Then go to PID advance, here make it true, limit is true, upper saturation 550 and lower saturation minus 550, and this anti wind up should be true, okay, and just click OK. Okay, so now this PID controller will compensate, okay, whatever the, whether the error signal is positive or negative. So compensation, it can be done by PID controller. So now this signal we have to process in such a way so that we can generate three reference signal, okay, sinusoidal reference signal, so that further we can process it through a PWM modulator. PWM modulator means which can convert some reference signal by comparing with the carrier signal, okay. So it can generate PWM pulses, and that PWM pulses is very useful for driving the switches of the three-phase inverter, okay. So next our aim is to how to make this signal into reference signal, okay. So here is our inverter, okay. So this inverter can take different types of input. So here our aim is to take internal modulator. So what will happen, it will generate internal carrier signal, okay, of 10 kilohertz. Okay, so internal carrier signal it will generate. So just we have to give three reference signal. Okay, so you can see this INA, INB, INC. So these three reference signal we have to generate here. Okay, here we have to generate with the help of this signal. Okay, and that information will go to this three-phase inverter, and this three-phase inverter will start working. Okay, so that things we have to do here. So how to do this? So this is very important to know. So first thing which is we need to do, that is this speed we are getting here, the quantity, that is the speed in the form of speed. Okay, so this speed we have to convert it into omega t form. Okay, so theta equal to omega t. Okay, so with this relation we have to make it in ramp signal. Okay, so omega t signal we have to make, then it will pass through sine wave. Okay, so then sine omega t it will become. Okay, then sine omega t minus 120 degree, sine omega t plus 120 degree. So like that we have to process. So how to make it in omega t form? So for that we have very simple formula. So to implement any formula we have to use C function block. Okay, so search C function block in the library. Okay, so C function. So take one C function from the library. Okay, and connect it like this. So here only one input is here. You can see this is the only one input this PID is giving output. Okay, so that is working as input for this C function. So double click on this C function and we will write here a very simple program. Okay, using C programming, so that it will convert theta into omega t form. Okay, so how to do this? So our input is omega. Okay, and output is omega t. Output is omega t, and any variable we will use or not, that I will check later. So first go to this function. Okay, and this output function is omega t is equal to theta. Okay. Omega t equal to theta. Now this is the output function, means our aim is to create omega t equal to theta. So some initial value also we will require here. So theta initial value, that is equal to 0. Okay. So just I define the initial value, then update. Okay, so it should update. So how it should get updated? So that is theta is equal to uh, with respect to execution rate, it should be updated. So omega is our input. So W star execution rate. Okay. I think execution underscore rate. Okay, plus theta. Okay, so now we have to use if statement. So if theta equal greater than equal theta greater than equal to star 3.1416. Okay, so this is the condition. Then what will happen? The theta equal to theta minus 2 star 3.141. Okay, so the purpose why we are doing this one, uh, I will tell later. Okay, in the later stage, if you are not getting this time, so in the later stage when we will finish the modeling of this one, then you will be understood that why we are writing this code. Okay, so it to generate one sawtooth type of signal. Okay, so that should be omega t. Okay, so omega t, we have to generate theta equal to omega t. That should be in sawtooth form. So to do that, we are writing this code. So after writing this code, just check here, syntax check. Now it is no error, it is showing. Now here we will come, and here you can see one variable is here. So that is the theta. So that variable we have to write here, okay, theta. So again, I am telling that this is your PID controller. Okay, this error, speed error is coming. So that is coming, suppose in the form of omega t. Sorry, omega means theta. Okay, so this theta we have to convert into omega t form. So in order to do that, we have chosen this input omega. Then we have taken one output omega t, one variable theta, and in the function we have written output function as omega t equal to theta, then initial function theta equal to 0. Okay, and in the update section we have written theta equal to omega t, sorry, omega star execution underscore rate plus theta, and if statement we have used that if theta greater than equal to star 3.1416, then theta equal to theta minus 2 star 3.1416. Okay, so this one is very important. Now, so it was here, it was, I will write here. Okay, omega, omega it is suppose, or you can write omega, it is omega actually. Okay. So now we are getting here, we are getting here theta. Okay, theta or equal to omega t. So this one we are getting here. Okay, so now the next step is to uh, pass it through the sine. Okay, so trigonometric function we have. Okay, so just search for trigonometric function in the library. Okay, in my case it is coming directly trigonometric function, but if your case it is not coming, just write trigonometric function. Okay, so this one, so bring it here and connect it like this. So now you are a little bit able to understand that why we have done this omega equal to omega t right now. So theta equal to omega t. So because we want sine omega t. Okay, we want sine omega t. So this is the sine. Okay. Now next one more we need, that is sine omega t minus 120 degree or plus 120 degree. So that also we will require. So just copy and paste here 2 times. Okay. So this one actually, let me write here. Just okay. So this one is nothing but sine omega t. Sine omega t. Okay. This one is sine omega t, and this one we will make it sine omega t minus or plus 120 degree, we can write. Okay. Either you can write minus or plus 120 degree. Okay. And here we will make it sine omega t minus 120 degree. Okay, so one we have to take as plus 120 degree, another we have to take as minus 120 degree. So I will do this one as minus. Okay, is good habit to have first one as minus. Okay, let me modify first. This one I will take as positive, okay, plus 120 degree, and this one as minus 120 degree. Okay, so here it is only sine omega t. So how to make it into one minus 120 degree or minus 120, okay, phase shift. So how to do that? So for such case we have to add some signal. Okay, so take some block from the library. Okay, take some block. So here is the some block. Search for some block in the library and bring it. Copy and paste two times. Okay, and take one more block, that is constant block from the library. Constant. Okay, constant block. So you can see here you have to take only constant block. Okay, this one. Okay, don't take constant impedance or any other things, just you have to take constant. So take this constant block and place here. Now connect it like this. So first one will be like this, means omega t. Here also connect omega t. Okay, and now make it, this one's take ts. Okay, it's execution rate, so that should be ts. And right here 120 degree, so we will take in radian. Okay, so that would be 2 pi by 3. Okay, so minus 2 pi by 3. So 2 pi by 3 means 2 star np, okay, star pi by 3. Okay, so minus 2 pi by 3 we have to take, minus 2 pi by 3. So just click OK and connect here. Similarly, copy and paste it, and here we have to take plus 2 pi by 3. Okay, plus 2 pi by 3. So make it or remove minus and make it 2 pi by 3. Okay, so now connect it here. So it will become sine omega t minus 120 degree, and connect it here. So it will become sine omega t minus, plus 120 degree. So now a reference signal always looks like this. Here I'm writing E ref is equal to Em, okay, amplitude into sine bracket omega t. Okay, like this. This is called our reference signal. Okay, for three phase, there will be three signal, right? Our inverter is three phase. So this is A phase, and this one is B phase. So B phase will be minus 120 degree. Okay. And this one will be C phase. So here it will be minus 120 degree. Sorry, plus 120 degree. Okay. So this is our main aim. So like this mathematical operation we have to do, so that we will get this type of signal. So till now we have achieved sine omega t minus 120, sine omega t plus 120. We need amplitude. Let me check whether I have disconnected or not. Okay. Any problem? Hello? Hello, Samir sir.
No, sir, no.
Okay, okay, because there was a call. Okay, so from this information only, we have to calculate the amplitude of the signal also. Okay, so to do that, what we will do, we will uh, divide it by 2 pi f. Okay, so that it will become a unity amplitude. Okay, and we can proceed it. So to do that, we need a gain. So search for gain. Okay, so take one gain block from the library and rotate it like this. Okay, control R you can use and connect it like this. Okay, no, it is the output of PID we have to take. Okay, output of the PID. So now inside this gain, place 1 by, okay, 1 by 2 pi f. Okay, the purpose is to make it unity. Okay, so we will take as base. Okay, 2 pi f we will take as base. So make it 1 by 2 pi f. F means 50. So 2 star np dot pi star 50. Okay. This frequency we have taken as 50. So as it is coming in the omega form, so that's why we have taken 2 pi f. Okay, and dividing by 2 pi f so that it will become a unity signal. Okay, per unit signal. So 2 pi f. So now this signal actually will become our amplitude. Okay, so to make it amplitude, uh, we have to place one limiter. Okay, so that it should not go beyond negative or beyond zero. Okay, so it should not become zero. Sorry, minus, because the amplitude should stay positive. Okay, so in order to do that, what we will do, we will take one limiter block. So search for limit. Okay, limit block and connect it. Okay, because our aim is to keep this quantity into per unit system. In the per unit system, maximum value is 1, right? So that's why we are taking this limit. Okay, so lower value should be 0 and maximum value should be 1. Now we will take one product. Okay, that means multiplication block. So search for product and hide its name. Okay, and copy and paste 2 times. Okay, so I will keep it here. So now this is your sine omega t. Okay, this is your sine omega t, and if you will multiply this with this one, so it will become em sine omega t. Okay, so for your simplicity here I am writing uh, em. Okay, so this is your em. From this side em is coming. Okay, and from this side sine omega t is coming, so it will become em sine omega t. Okay, em sine omega t. So similarly here also we have to place. Okay, and connect it here. Let me modify a little bit. And for this one, here we have to connect And for this one, here we have to connect. Okay. Now you have got Em sin omega t, Em sin omega t minus 120 degree, Em sin omega t plus 120 degree. Okay. So now all this signal we have to joint. Okay. So in one line, all this pass as a three-phase signal. Okay. So for that we have to take bus join. So search for bus join and select it. Double click on it and make it 3. So now place here means connect like this. Okay. So now this signal, okay, all this signal we have to send to our inverter. Okay, here we have to send. So for that purpose, again we have to use one go to block. Okay, so just search for go to and take this signal go to. Okay, connect it and make it here EM ref. Okay, EM ref means ref signal. Okay, reference voltage you can say. Okay, hide the name. Now this signal we have to send here. Okay, here we have to send. So what we will use from. Okay, take from signal. So from search for from and take signal from block. Okay, so hide the name of this one, double click on it, make it here EM ref. Same name we have to write here. Okay, click it, again double click on it and check with which signal it is matching. So you can see here go to 2. So if I will click here, it will take us to that signal where it is matched. Okay, so EM ref will go there. So EM ref will come here. Okay, so now in this one we have 3 signal, right? EM sin omega t, EM sin omega t minus 120 and EM sin omega t plus 120. So all these 3 signal again we have to demarks. Okay, so to demarks any signal we have to use bus split. Okay, so search for bus split. So this one will come. Okay, double click or okay, drag and drop, whatever you want to do it. Double click on it and make it 3. Okay, make it 3. Hide the name. So now first signal it is sin omega t. So it will come to INA. Second signal is sin omega t minus 120 degree. So it should be connected to INB. And third signal is sin omega t minus plus 120 degree. So that should be connected to INC. Okay. So now I will let it dezoom. Okay. So you can see here we have created the controller, almost it is ready. Okay, so this is the controller output and this will go to inverter. So here is our inverter. We have taken here internal modulator. Okay, carrier frequency 10 kilohertz. Okay, and this is dead period, that is we have taken 5e power minus 6. Okay, and just click OK. So now all these are connected. One signal is remain unconnected. This one is EN. Okay, so purpose of this EN is to turn on and turn off the inverter. So in order to turn on and turn off the inverter from the Hil SCADA, we have to use SCADA input. Okay, so Again, search for SCADA input. So
So
take
what
one
is the
SCADA.
carrier phase offset frequency? Hello.
Carrier frequency 10 kilohertz. Carrier frequency 10 kilohertz. Okay. So here is your SCADA input. So double click on it. So first rename this one. Okay. And make it EN. Okay. Or enable. Okay. Give the name of this one as enable. And connect it here. Double click on it. Keep it minimum value 0 and maximum value 1. Default value 0 and the execution rate TS. Okay. Again, I'm showing you. You just note it. The purpose here is to do on and off. Okay. Enable means it will do only on and off. So on means 1 and off means 0. That's why minimum value I'm taking 0 and maximum value I'm taking 1 and default value 0. Execution rate is TS. Okay. Right. So now a little bit try to understand uh, when the inverter is off, then controller also should get off. Okay. In order to enable such a function or such an activity, we have to do some special arrangement. Okay. So how we will do that special arrangement? That means this one will do enable functionality of the inverter. Okay. Either it will do on and off or it will do okay. So what I will do, I will take one product block here. Okay. Erase it and try to understand why I'm doing this. Okay. And take here one from block. Okay. Take one from block and double click on it and give the name here enable. Okay. Enable. Click OK. Connect it here and hide the name of this block. Okay. So what I want to do, so this information will come from here. Okay. So take here go to block. So take one go to block here, double click on it, rename this one as enable. Okay. Click OK. Again double click and ensure it. Okay. So you can see here it is connected. So this enable information will go to the controller, and when the enable is off, okay, means when it is off, 0 will come. Okay, it will give 0. So once 0 will be multiplied with this signal, the entire system value will become 0. Okay, so the PID controller will be stopped. So like that function I am doing here. Okay, try to understand. I'm little bit de-zooming it. So you can see here it will do on off. So on means 1 it will supply. So if it is coming 1, then no problem, it will work. Off means it will supply 0. So once it will come 0, what will happen? This entire controller stop working because signal will become 0. Okay, so like that activity I have done here. Okay, so in between, if you people have any question, you can ask. Okay, so now we will do some. Okay, we want to measure the frequency. So this is omega t, right? So omega, so from the omega we will calculate frequency. So take one probe. You know very well that if anything you want to visualize on the Hill SCADA, so for that we will require probe. So rename this one as frequency. Okay, frequency, and connect it here. Okay, but this will give a radian per second. Okay, but frequency we need uh, in the hertz. Okay, so for that, what we will do, we will divide this one, okay, by using the gain. So here is gain, so copy and paste this one only, and vertically flip it and connect it. So omega 2 pi f is coming. Okay, so here we are getting 2 pi f, so divide it by 2 pi. Okay, divide by 2 pi, so the result will become f. So f we will get here, right? So here what I am doing, I am dividing by 2 pi. Okay, so that f will be in the remaining signal. Okay, so it will give us frequency. So now save it. I think almost it is done. Okay, if you guys having any problem, you can ask me, whether it is conceptual or whatever.
What is the value of gain?
Which gain? Gain 1 or gain 2?
Gain 2.
Gain 2 is 1 by 2 pi. So in order to write here 1 by 2 np pi. Okay, here I am clicking and you can see, you can read here 1 by 2 star np dot pi. Okay, okay, so now I will try to compile this. Okay, so first step is here we have to click, and now it is telling some mistakes. Okay, what is the mistake it is telling? A three-phase inverter, PWM modulator, IN. Okay, there is a mistake in IN, bus split 2. So let me check bus split 2. Yes, here it is. Yeah, bus split 3. It's okay. But what is telling here? Go to, is this one also right? So this is sine omega t, sine omega t, sine omega t. What is the mistake here? Incompatible dimension. Why it is telling incompatible dimension? Let me check. We have used bus join, and then here we have used bus split, bus second, third. Okay, now let me check here. Okay, I think inherit. Constant. Okay, okay, okay. Inside the constant, we have used different. And now, okay, NP. Yeah, here we have done mistake. So check it. NP dot pi. Okay, it should be NP dot pi. Okay, so minus 2 NP dot pi by 3. So here also check it. This one is star. This should not be star. It is NP dot pi. Okay. So again here let me check. Yes, it is correct. Here also let me check, it is correct. So now we will try to validate. Okay, still validation passed. Validation passed. No problem. Validation passed. So what wrong is here? Nothing. Okay. So it is validation passed. So now we will click on the compile. Okay. So what it is telling, let me check. Okay, between min and max. Okay. Default value should be between min and max. So here we have taken 0, so we take 200. Okay, or 500 you can give. Okay. So here it is check 200 and 2000, and in between default value we should have to take in between. So we have to take 500. Okay, or 600, 1000, 1400, whatever you can put here. Okay. Okay, so now we will try to compile again, and you can see it is compiling. Validation passed. Okay, you can read here in the red color, validation passed, and it is compiling the model. Okay, successfully it will compile.
So will you please repeat the value of constant 2 and constant 1?
Constant 2 and constant 1. Yes, there is NP. This NP dot pi. Earlier we have written NP star pi. Okay, so star would not be here. It is NP dot pi. Okay, so value is same. In the first case here is minus and NP dot. Okay, in the second case it should be plus. Okay, means no sign, but NP dot pi. So you can see here compilation finished successfully. Right. So now we will click here. Okay, we will click here and we will load the model into the Hil SCADA. So just click here and proceed. Okay, so now load model to virtual hill. Select load model to virtual hill. And it is taking us to the Hil SCADA. So in the Hil SCADA, we have to create the SCADA panel. Okay. So as panel itself is telling, panel means it is a board where you can have some meter, some gauze, some slider. Okay, all these things we can have, some knob we can have, so that we can monitor as well as we can control some parameters. Okay, so to do that, this we have to create this panel. So how to create this? So just click here, create new panel. Okay, and here first thing which you have to take this one, capture and scope. Okay, not necessary, but always I prefer to use this one. Okay, so capture and scope, double click on it and go to signals, means click here on the signals, and you can add different signals like this. So what are the signals I want to add here? So first one which I want to add, so that is the uh, output terminal voltage of the inverter. So VA, then VB, VBC, and VCA. VCA. Okay. And so all these three will be in one viewport. Okay, so checkbox provided, you just click on the checkbox. The next signal I want IA. Okay, IA, then similarly IB, okay, then IC, okay, just click here and search for IC. Here it is IC. Okay, so IA, IB, IC means inverter output current. Okay, so all this I want to visualize in this, okay, viewport. Now I also want to visualize the of the uh, speed of the motor. Okay, so speed of the motor is here W and electrical torque is Te. Okay, so we have to search here W and Te. So here we will search for W. Okay, so where we can have it, here it is. Okay, and torque also we want to see. So torque we have taken as Te. Search for Te. Okay, so here we can have it. Okay, so now cut it. Next thing is that to define some source parameters. Okay, in our model we have a source that is three-phase source, right? So that three-phase source we have to define here. So how to define the source parameter? So here is a panel initialization. Okay, so if you will see here, okay, this Python type symbol is here. Okay, so this is called panel initialization folder or panel initialization. So here we can initialize some sources like PV or three phase source, single phase source, whatever the source, okay, that we can initialize. So once it is initialized, always this value it will take. Okay, so for that purpose, just click here, edit in code editor. Okay, and place your cursor here. But before that, which one we want to initialize? We want to initialize the source. Okay, which source? This VS1. Where is VS1? Here is the VS1. You can see this is the source. So this one we should initialize. No, we have taken here 0, 50, 0. So that would not work. So in order to initialize this one, there is a method. Okay, so we can initialize that value in the panel initialization. Okay, so here is the panel initialization. So just we have clicked, then code editor, we have clicked in the code editor and we will come here. Okay, so here is the sources. In the sources we will get VS1. Okay, so now just feed here 230. Okay, 230 and click enter. Okay, so 230 50 hertz 0. Okay, and insert. So keep your cursor here and insert it. So you can see that VS1 equal to RMS 230, frequency equal to 50 hertz and phase equal to 0, 0.0, and we have chosen no harmonics. So it is showing 0. Okay, so like that we can initialize the source. Okay, so source initialization is over. Now we will do on and off. Okay, inverter on and off. So for that we will take one combo box. Not combo box we will not take. Simply I will take one checkbox. Okay, so just take one checkbox, drag and drop type. Okay, and double click on it. Rename this one as inverter on and off. On, off. Okay, so how to do this on and off? So go to code editor. Okay, so here is the code editor, and here already the program is written. Okay, so what it is telling, do something when checkbox is checked. So when the checkbox is checked, the inverter should be off. Okay, inverter off means enable should be 0. So where is the enable? Here is the enable. Okay, this one. This one we have to consider. So this one, practically this one, what is? It is SCADA input. Okay, so we have to go to SCADA input. So here is the SCADA input. You can see total we have used 3 SCADA input. Okay, but we require this one, enable. Okay, so just keep your cursor and insert it here. But this value should be 1. Okay, because when it is checked, then inverter should be on. So when it will be on, when this value should be 1. Okay, remove this unnecessary space. And when it is unchecked, okay, so during unchecked, this value should be 0. So just insert, okay, and keep it enable 0.0. Okay, so try to understand, if enable equal to 1, inverter will turn on, and else, okay, 0.0, for 0.0 it will be turned off, means inverter will be turned off. So that function is being done here. So save it and come out. Okay, so next thing is we will apply some load also, right? So in order to apply some load, what we have to do? Okay, also reference. We will apply some reference also, right? So a reference, for reference we will take slider. Okay, so here is the slider. Okay, double click on it and make it here 0.02 2000. Okay, minimum value is 0, maximum value 2000. Okay, and a step you can have 10 step. Okay, and go again code editor. Okay, so where is the reference speed? So inside the SCADA input, here is the reference speed, right? This one. So keep your cursor here and insert it. Okay, and here it is written in 500. Okay, so don't take 500, write in, and by default it will come input value. So select input value. Okay, so that whatever the input you will give, that it will take. Okay, so just save it and cut it. So now what will happen, if you will apply like this? Okay, this variable type of value we can apply. So this is your reference speed. So right here, reference speed. Okay. Reference speed. Reference speed. Okay, again double click on it. Okay, and on start, what value it should take. So in order to take default value, just make it microcode. Okay, make it microcode so that it always take the default value when the simulation will start. Okay, we will take also one indicator in order to visualize. So to indicate something, we have a LED. Okay, so here we can place one LED and we will check whether the inverter is turned on or not. Okay, so to do that, what we will do, it is LED, right? So which one we will take? Let me check. Currently it is not possible. Later I will see. Okay, so now we will take one digital display. Okay, or one digital display we will take and place here to read the speed of the motor. Okay, so speed. Okay, speed of the motor, and which signal is speed? W is the speed. Okay, W in RPM. Okay, so take here W. Okay, just search here and W. So that W is nothing but the speed of the motor. Okay, you can see here. Here you can see this is W. W is nothing but speed, RPM speed. Okay, so now almost it is done, and I will check whether it is working or not. So what I am doing, just starting the simulation. Okay, now you can see speed is 0. So here is the inverter on and off. Okay, this checkbox will do inverter turn on, turn off. So it is unchecked. So it is off. Okay, when we will check, it will start turned on. So you can see speed is here. Also, you can see these are the voltage, these are the current. Okay, this is the torque. Okay, now speed is how much reference we have given, 880. So it is showing 878, or it will come around 880. Okay, so now some other parameters also we can visualize. Okay, so to visualize this one also, we can switch to embedded mode, and it will become like this. Okay, so you can keep here, you can little bit make it bigger. Okay, now I will place it here. Okay, now if you want to increase, you can increase this. Okay, so you can see we are increasing the reference speed. Okay, so speed is also increasing 1440, so it will achieve 1440 after some times. Now we will apply some load also to the motor, right? But still we have not applied any load. So in order to apply some load, we have to do some arrangement. So how we can apply the load, you can see here. This is the Hill SCADA input. Okay, that is connected to the load input. Okay, so this one we have to link with the SCADA panel. So what we will do, so again we will take one slider. Okay, the slider we will take here and double click on it, make it apply load. Apply load. Okay, so it is 0 to 100 is sufficient, and 1 is the step size. So again click edit in code editor, and here we have to link the load. Okay, so a load will be applied by this one, this signal. Okay, so this block, this is the SCADA input block. So just click, so it will come here, and make it here input. Okay, so just write here in. Okay, so input value will come, choose this one, input value. So what will happen, whatever the input we will give, that it will take. So save it and come here. Again double click on it and go to the advanced. Okay, in the on start we should take the default value. So in order to enable a default value, this setting we have to do. Okay, and this one also we had done. Yes, now we will apply some load. So you can see. Okay, okay, we are applying load. If it is 0, so you can during 0 you can see here the value is 0.09. Okay, and if you will apply this, okay, then it will change. Let me again run and take other graph also. This trace graph also you take. Okay, and in this trace graph, connect one torque. Okay, T electrical torque, and also connect speed also. Okay, so that we can see whether it is varying or not. So omega. Okay, and frequency, not two, only one I will take here. So torque, and again take one more trace graph. Okay, here, and here we will take frequency. So frequency we have taken as frequency. So search for frequency and connect it. So now I run the simulation. Okay, now it is showing each and everything. So suppose it is 0, then you will see the torque, what torque it is showing. Okay, so now I will increase this one. So you can see here. Okay, so like this variation will come. Now you can apply some different torque also. Okay, so that could be sawtooth or square wave. Okay, uh, different types. So I want to apply triangular type of uh, load. So in order to do that, here we have to make some changes. Okay, so what we will do here, we will use one a little bit different arrangement so that step by step we can apply different types of load. Okay, so for that what we will do, we will take one multi-port switch. Okay, so search for multi-port switch. Okay, so here it is multi-signal switch. Okay, so take this multi-signal switch. Okay, multi-signal switch, and disconnect this one. Okay, and connect it here. Okay, so let me tell you a little bit about this multifunction switch. Multifunction switch is nothing but a switch where you can have multiple port. Okay, the control, okay, this control signal, when it will be 1, okay, then this IN1 signal will pass. When this will be 0, sorry, 1, then IN1 will pass, and when it is 2, then IN2 will pass. So like that function it will do. So you can read from here, that should be integer value, and if if CTRL equal to 2, then signal 2 will be forwarded. Okay, so I'm going to take only two signals. Okay, so one I will take triangular, and another I will take as rectangular. So double click on it and write here triangle. Okay, triangular wave. So triangular wave it will come. Double click on it, and 0.5, 0.550. Okay, we can have, no problem, and just change this value. This one we will make at TS. Okay, and one more. So this one is first one. Give the name here as T1 load. Okay, T1 load, and one more load here we will give, that is square wave. Okay, so find square. Okay, square wave source, and place here, and it will be 0, high state 1, then 0. Okay, 50 hertz. Okay, and you make here it is TS, like this only, and connect it here. Okay, and here make it T2 load. Okay, T2 load is nothing but square wave. Okay, so square type of load will be applied here. Okay, in this one triangular type, and in this one square type load will be applied. Okay, now I will connect it here. Okay, and in this one we will make some changes. That minimum value I will make it 0, and maximum value I will make it 2. Okay, so when it will be 1, then T1 load will be passed to the motor, and when this value will be 2, then T2 load will be passed to the motor. Okay, so now save it again and compile the model. Okay, it is telling some value is problem in the load. So here what is the problem? Okay, minimum value, so I will take 1, default value I will take 1. Okay, so now try to compile this. It will start compiling. Okay, so accordingly we have to make changes here also, because in the load SCADA we have changed the value, that is 1 to 2, right? So we have to make some changes. So apply load. In this apply load we will make some change. Oh, before that, one more thing we have to do here. Because this one maximum value it will generate, that is 1. Okay, highest value it will generate amplitude, that is 1. Okay, and this one also will generate maximum amplitude, that is 1. So to provide some more value here, we have to use one gain. Okay, so 1 will become 4, like that. So we will use one gain here, rotate it and place here. Okay, and make it this gain value as 4. Okay, so what will happen if it is in this side load will be 1, so that will be multiplied with 4 and it will become 4. Okay, so 4, ultimately 4 amplitude will be applied to the okay. So you can understand why I'm using this gain in order to amplify this load. Okay, because this load value maximum will be 1. So now again we have to compile, because we have changed some values in the circuit. Okay, so compile your model and load it to the Hil SCADA. Okay, so now this one we have to make some changes in this one. Okay, if I will start running, so you can see there is some problem. Okay, it is not, even though it is running, but this is not correct. Okay, so we have to remove this one. Okay, and instead of this one we will take text box. Okay, so that we can apply 1 2 like that. So here write apply load, apply load and go to here. Okay, edit in code editor, and which one we want to change? This one, load. Okay, so insert this one and write here in. Okay, so input value. So whatever the input value we will take between 1 and 2, it will be applied to the machine. Okay, this is the purpose. And in order to enable the default value, as I said earlier, so here you have to make it microcode. Okay, so on start, click on start, and in the on start microcode is here. Okay, that one you have to select. So now start the simulation. Okay, so suppose it is okay, inverter is off, right? Make the inverter on, and here it should be 1. Okay. So here you will be observing that how this torque is changing, because this when this apply load is 1, then triangular type of load is being applied to the machine. So because of that, this type of variation is coming. If I will make it a square type, okay, let it run for some times, then only will be able to understand the effect. Okay, you can see that the torque, here is the torque, no? This torque is sometimes going positive, sometimes going negative, because we are applying negative and positive, means triangular type of load. That's why this is happening. So now we will change the load to square. Okay, so just we have to make here 2. Okay, so now square type of load will be applied. See, the okay, so you can understood how to make a induction motor drive system in Typhoon Hill. Okay, so do you have any problem? Audience, please ask if you have any questions. You can ask. Okay, little bit. Let me check here. I want to see these two waveforms. Okay. So this two waveform, we want to see whether which type of waveform is coming here. So here it is 1, then 0, then 50. Okay, little bit faster we will make it 100. And this is also I will make not 1. Minimum value I will take 0 and maximum I will take 1. Okay, and frequency I will take 100. So now compile the model. Let me see these two waveforms and how the machine is reacting against these two load. Okay, so just I will run the simulation, and here I want to see this to load signals. So that is probe 1 and probe 2. Probe 1 and probe 2. Okay, this one I will keep here, and this two I will place here. Okay, so like this, you can see this probe 1 is for triangular, okay, and probe 2 is for square. Okay, so now this one is completed. If you guys having any problem, please ask me. Okay, so next is I will take 5 minute rest, and then I will start. Hello, Samir sir. Hello. Hello. Hello, Samir sir.
Yes, sir. Wait 2 minutes, sir. We are calling.
Okay, okay. Please call Samir sir. Okay. Anyone
Yes,
can.
sir. Samir sir is in the meeting, sir. It is a
Okay, okay. Actually, I want to stop today's session here only because I have some work, other work. Okay.
okay. Yes, sir.
So, what I will do?
Uh,
Samir sir will come or what? In what time
yes,
he
sir.
will
We will.
come? Hello. Yes, Jed. Mr. Jed.
Yes, sir. 15 minutes to half an hour. It will last.
Okay, he will come within 15 minute or 30 minute, right?
Yes, sir. Yes, sir.
Okay, okay, okay. So what I'm telling that today I'm stopping the session here only. Okay,
Okay, sir.
because I have some other work, urgent work, and no other faculty means our members are available for today. Okay. So tomorrow, please try to connect after just 2:15 at okay.
Okay, okay, sir. We will connect at
Okay.
2:15.
So if Samir sir will come, just inform him that today we have stopped the session okay early because I
Okay,
have
sir.
some work with other customer also. Okay.
Yes, sir. We will
Okay,
inform you.
Okay. So I'm stopping the session. Okay.
Okay. Thank you, sir.
You're welcome. And if you have any
thank you, sir.
problem, then you can discuss for 10 or 15 minutes. But after 15 minutes, I will be busy with some other person. Okay. So do you have any problem?
No, sir. We have no that.
Okay, okay. Then
Yes,
okay.
sir. No
Please,
doubt, sir.
okay. Tomorrow try to connect at 2:15. Okay, 2:15 p.m.
Yes, sir.
Okay, sir. We will try.
Okay, okay. Okay, so I'm logging off. Okay, bye.
Yeah. Thank you, sir.
Okay, bye.